The journey from mathematical certainty to geometric nuance. Exploring the balance of spatial forces. The essence of the research lies in a purposeful transition from the universal stability of enclosed volumes to the sensitive, path-dependent nature of open boundaries. The sheet begins with a foundational discovery that for any completely closed shape, such as a sphere or a cylinder, the interaction between the position of a point and the surface itself always results in a perfect state of equilibrium. This occurs because the underlying field radiates directly outward from a central point, possessing a radial symmetry that lacks any internal twist or rotational swirl. As the logical flow of the study suggests, this phase uses interactive visualizations to provide physical intuition, proving that within a closed system, these spatial forces will inevitably cancel each other out. The sheet then reaches a pivotal turning point where the focus shifts from the volume trapped inside a shape to the geometry of the boundary edge that defines an open surface. This transition reveals that once a surface is no longer closed, its behavior is no longer guaranteed to be zero. Instead, it becomes a reflection of how the shape is positioned in space. This distinction is best understood through a comparative analysis of two scenarios. In the first scenario, an open surface like a flat disk remains perfectly centered around its origin. Because it maintains rotational symmetry, every force on one side is met by an equal and opposite force on the other, resulting in a total sum of zero. However, the second scenario demonstrates what happens when this balance is intentionally broken. By shifting the surface away from the center, the symmetry is destroyed. The side of the shape further from the origin gains more leverage, creating a net twisting effect or torque that prevents the forces from canceling. Ultimately, the logical progression established across the diagram shows that while closed systems are inherently balanced by their very nature, the character of an open system is defined entirely by its boundaries' relationship to the center of the field.